Good morning, everybody. I wanted to start with going over page 458, some of the problems on 458. I heard from some of you, and I know that this is something maybe we need a little extra practice with. So let's start with 5/8 times 400. That was the word problem. So 5/8 times 400. So what we could do is we could take our 5/8, move it over here, and let's put 400 over 1. So 5 times 400 is, 5 times 4 is 20, right? And then we have 2 zeros. So it looks like 2,000. And 8 times 1 is 8. So this is an improper fraction. So we're going to have to divide 8 into 2,000. Can 8 go into 2? No. Can it go into 20? Sure. 2 times 8 is 16. We get 4. Now we're going to bring down our 0. 8 goes into 40 5 times. 5 times 8 is 40. We subtract and get 0. And we bring down our last digit, which happens to be a 0. 8 goes into 0 times. So you know me, I always like to totally finish off that division problem. So it looks like it's going to be 250 miles, I believe. All right, let's go on to the next problem. 8 times 7/8. So again, we're going to multiply. So we're going to do 8 over 1 times, let me move that down just a tad. 8 over 1 times 7/8. And we end up with 56 over 8. And that's going to give us, of course, the answer of 7. Now we have this one, 60 times 5/6. So if we do 60 over 1 times 5/6, we end up with 5 times 6 is 30, plus the 0, of course. So it looks like 300, and then 1 times 6 is 6. So now we're going to divide 6 into 300. 6 goes into 35 times. 5 times 6 is 30. Get 0, bring down our 0. 6 goes into 0 times. And it looks like we end up with 50 as our answer. 50 for that one. This was page 458. So let's review another quick problem though. What happens if I had something like 3 4/5 times 1/2? So here we have a mixed number times a fraction. So I heard from some of you, like, what do I do here with this problem? And that's a really good point. I'm glad you brought that up. So a student in my class said, well, let's take this problem here and turn it into an improper fraction. So let's do the 5 times 3 is 15 plus 4, which would be 19 over 5. Now we can multiply it. So we're going to end up with 19 and over 10. Now, it's an improper fraction. So when we divide 10 into 19, we get 1 9/10 as our answer. So we took this improper fraction, mixed number, and we turned it into an improper fraction. So let me review that real quick. To do that, you would do your denominator times your whole number plus your numerator. So 5 times 3, 15, plus 4 is 19. That's how we ended up coming up with that answer. So let's see, is there another way to solve this, do you think? I'm always looking for those other ways. What if I did like 3 times 1/2 first? So let me just see that. What happens if I did 3 times 1/2? So I'd have to put 3 over 1, right? And I get 3 over 2, which is an improper fraction. So I get 1 1/2. right? But then I'd have to do the 4/5 times 1/2, wouldn't I still? So 4/5 times 1/2. Let me use a little. We would end up with 4/10. So if I added these together, would they equal 1 9/10? Well, 1/2 would have to be turned into 5/10. So yes, technically when I added this one together and this together, remembering finding the common denominator, they would equal 1 9/10. But I kind of like this way, just turning this mixed number into an improper fraction first and then multiplying. It seems like it's less steps. What do you guys think? Leave me a comment if you've been using one of those ways and which way you've been using and why. If you want to tell me, like, if you think it's easier, but why? Is it less steps? Does it just seem to gel with you? All right, today though we're going to be looking at this problem: 6 divided by 1/2. So we're working with whole numbers divided by a fraction. So what do you guys think this answer is going to be? What do you guys think? What do you think this answer is going to be here today? Okay. Well, some of you are probably going to say, well, it's 3, right? So maybe sometimes if I draw a picture out of things and I come up with a story, sometimes it helps me. Let's say Talisha is making cakes for field day. Okay? We're having a virtual field day this year, but she's going to make cakes anyway. She has 6 cups of flour and needs 2 cups to make 1 cake. Because what we're doing is we're kind of thinking about this problem as just being with whole numbers. So 6 divided by 2. So if she's got 6 cups of flour, here's our 6 cups of flour. There's 3, 4, 5, 6. So if you've been baking, you got to make sure those cups of flour are leveled, right? And she needs 2 cups to make 1 cake. So here's a cake, here's a cake, and here's a cake. So if you are saying, well, it's going to be 3, there's a good chance that you are correct, because I am seeing here that we get 3 cakes that we can make, that Talisha can make. So one way to think about division is to think about how many 2's are in 6, right? Division is really just breaking things up into groups. Sometimes we use multiplication to help us with division, such as, well, what would I multiply 2 by to get 6? So we can think of division as, hey, let's break this up into groups, right? We're going to break it up into 2 groups. How many would be in each group? And sometimes when we think about division, we think about saying, well, what times 2 equals 6? Sometimes we take away that division sign and turn it into a multiplication problem to help us. So let's look at 6 divided by 1/2 again. If we want to solve 6 divided by 1/2, we can think about it as how many halves are there in 6? What times 1/2 equals 6? How would we write it as a missing factor problem? So what they're saying is blank times 1/2 equals 6. So what times 1/2 equals 6? So how many halves are in 6? I want you to pause the video here for a second, and I want you to try to solve this. So we went from 6 divided by 1/2 to thinking, how many halves are in 6? And now we're kind of using it as a missing factor. What times 1/2 would equal 6? Remember this work earlier I did, though, was just to show 6 divided by 2, right? When we're talking about whole numbers. But remember, we're in fraction world, so not everything's going to be the same. So I'm thinking that it's going to be 12. That this answer right here is going to be 12. There's 12 halves in 6. And the reason I say that is, if I would draw it out, here's my 6, right? I need one more. Here's my 6. So if I was to cut each of these in half, how many halves would I have? Would I have 2 here, 2 here, 2 here, 2 here, 2 here, and 2 here? 2, 4, 6, 8, 10, 12. So that's where I'm getting that answer of 12. So what does that tell us about this division problem? Maybe we thought the answer was 3 at first, right? Because we were thinking like, well, if I cut 6 in half, it has to be 3. That's because we were thinking of whole numbers. That's 6 divided by 2. But remember, we're in fraction world, so not everything's going to be the same. So let's rewrite that problem. Let's do 6 divided by 1/2. And let's see. I know from previous experience that I have to do 6 over 1 because 6 is a whole number, right? So I'm going to say that I have to do 6 over 1 because to me that makes sense, right? Because 6 is a whole number and I don't want to change its value. And I'm going to bring down 1/2. So how can I make this into 12? I know the answer is 12 because I literally just drew it out and worked it out. So how can I make this answer 12? 6 times 1 is 6. 1 times 2 is 2. So that would give me 3. That'd be right back over here with the whole number kind of theory. But this is division of fractions. Oh, you know what? If only this 2 was on top, then I would have 6 times 2 equals 12. This is what I mean. If only I could do this and turn this into a multiplication problem. Watch, see? I would get 12 over 1, which equals 12, which matches what I drew out. 2, 2, 2, 2, 2, 2. But can I do that? You can do this. So let's go over here. I'm going to rewrite this so we don't get too confused. And this is the big part of the lesson, is that I want to rewrite this. By the way, our name of the day is Joe Ryan. Joe Ryan is our name of the day. So let's get back to this problem. And you want to watch the rest of this video. You don't want to just skip. So we're going to say 6 is over 1 still, because that seems like a legit rule. Is that because this is a whole number, to put it over 1, so we're not changing that value. But this 1/2, we're going to bring this down, and we're going to flip it. It's going to be this now. And this is called the reciprocal. It's actually a real thing in division of fractions. You take this and you flip it. And then this comes down, the division sign comes down to become a multiplication sign. So let's review. The 6, we just brought it down, put it over 1. That should be like ingrained in your brain already. This 1/2, because this is the number of groups we're making, right? Like we're breaking this up into this many groups, right? Think about it that way. This 1/2, we can bring it down, but we flip it. So instead of the 2 as the denominator, the 2 is now your numerator. And then instead of 1 as the numerator, it's now your denominator. So we literally just flipped it. And that word is called the reciprocal. It's a real word. It's a real math term. We're going to talk about more tomorrow. And this division sign just becomes a multiplication sign. So now we can do 6 times 2 is 12. 1 times 1 is 1. 1 goes into 12 times. So this matches our answer over here that we drew out. So now you're probably wondering like, well, Mr. Eckrich is going to assign some workbook pages. I am. How am I going to do this? Well, if we turn to page 460, I'm going to help you out with the first problem. It's another reason not to skip through these videos or play them fast, as some of you are saying. Felix has 2 yards of ribbon. He needs 1/4 of a yard to make 1 bow. How many bows can Felix make? So he has 2 yards of ribbon. He needs 1/4 to make a bow. So we're really having 2 divided by 1/4. How many bows can he make? Well, a way to do this is to just draw it out for these initial problems, right? So here's my 2 yards of ribbon. I'm going to break this into fourths. So there's 1, 2, 3, 4. 1, 2, 3, 4. There's 4 here. So how many bows can I make? Or Felix can make 8 bows. So some of you are like, I like that drawing it out. It really helps me to visualize what I'm doing. Others of you are like, well, I want to do what Mr. Eckers just said. So I'm going to put 2 over 1. And the 1/4 I'm going to flip. It's going to become 4 over 1. And then the division sign becomes a multiplication sign. And I get 8 over 1, which gives me 8 bows still. I really would like to see you guys today really play around with just the drawing out so you can really get a good visualization. And then we'll move into this. I know some of you are having your parents are making you watch Khan Academy, which are great videos. I love Khan Academy, so they're smart parents. And they probably skipped over this part and went more to this. But I really want you to see that visualization. Have a great day, guys.